Bismillahirrahmanirrahim. Dear students, grade 11, and we are going to start today lecture number 64. Yesterday we did the Hess's law of constant heat summation. Hess's law of constant heat summation, yesterday I told you to calculate the enthalpies of the reactions. When the chemical reaction complete in one step or several steps, the enthalpy will be always same. And yesterday we done two examples for this. Then I told you that Hess's law of constant heat summation used to calculate to determine the enthalpies of reactions indirectly. We calculate enthalpy of reactions indirectly. So here is the example. You have to follow very well mathematical calculations, and you have to listen very carefully the procedure how I am going to calculate the enthalpies of the reactions according to Hess's law of constant heat summation change calculations. Enthalpy change calculation. So, if you see example number 11.5, the question is that maybe in the equation form given in the examination, maybe in the explanation form or only description form, only they put the values. Just like calculate the heat of formation of methane. Calculate the heat of formation of methane. This is the question. Heat of formation of methane gas. Change in enthalpy at their standard states. Formation of methane. This is the question mark. So this will either given the equation form, mostly they give descriptive form. Heat of formation of methane, question mark. So it is formed from 1 mole of carbon solid, must write their standard states, and hydrogen we put H2 and multiply by 2. So this is the question. Calculate the heat of formation of methane by using Hess's law of constant heat summation, by using indirect method, indirect way to calculate this one. So some information will be provided from the examiner. He said that heat of formation of 1 mole of water, heat of formation of 1 mole of water will be provided, the value will be given to you, 285.5 minus 285.5 kilojoules. This will be provided. And how you balance it? Hydrogen gas plus 1 oxygen. Don't multiply by 2 because this value is only for 1 mole. This value is only for 1 mole of water. That's why I don't multiply this. Without multiplication, multiply by half to balance it. So half this one. So this is the 1 mole of the formation of the water or combustion of hydrogen. Third one, this is the equation number 1. This is the question. Now equation number 2. Formation of 1 mole of carbon dioxide gas minus 393 point. So according to your book, 5 kilojoules. kilojoules, or we can say this is the combustion of the coal, combustion of we call carbon or formation of 1 mole of carbon dioxide gas from the 1 mole of carbon solid and 1 mole of oxygen gas. This is the equation number 2. These will be values will be provided for you with a description, and you have to write equations yourself. The third equation is, we are going to form 1 mole of methane. So you are seeing that in methane there is 1 mole of carbon and 2 moles of hydrogen. In the last equation you will get this. But there in the water, there is a carbon dioxide gas. There should be no water and carbon dioxide gas. That is why the scientists use combustion of natural gas methane, which are going to be formed. Combustion process always in the presence of oxygen gas. Presence of oxygen gas is combustion process. When the fuel is going to be burned completely to form carbon dioxide gas and water, and data is not for the combustion will be provided, and that is minus 890.4 kilojoules. Now, this is the combustion of 1 mole of methane. This value 890.4 kilojoule is for 1 mole of the methane here. So without multiplication of methane, balance it. There are 4 hydrogen atoms and there are 2, so multiply by 2 here. Then carbon is 1, okay, carbon is 1. Oxygen, there are 2 and there are 2 oxygens, so multiply by 2. So this is the balance equation. Now students, this information will be provided from the examiner in the form of equations like this pattern, or maybe he give you only explanatory informations like this one. We have this question. To get this equation, we have to use these 3 informations. Now you can see that there is no carbon dioxide gas, there is no water in this equation. It means that we should cancel these. So how we are going to cancel? This is our combustion equation, main equation, combustion equation. So there is a 1 mole of carbon dioxide gas. So we will not multiply this equation. We will write as it is. There is a 1 mole. See the combustion equation, main equation, combustion equation. In combustion equation, see the combustion. There is a 1 mole of carbon dioxide gas. That's why we will not multiply. So I am going to write in as equation number 4, carbon equation number 4, carbon, solid, oxygen, gas, to give carbon dioxide gas, delta H naught, formation minus 393.5 kilojoules. Okay, now you are seeing there are 2 moles of water in the main combustion equation. So multiply this equation by 2. So this is the equation number 5. Now I am going to multiply by 2 hydrogen gas. Now this will be a 1 mole of oxygen gas, and you will get 2 moles of water liquid. So delta H naught formation. So I must multiply by 2. I must multiply by 2. So 2 multiply by 285.5 is equal to 2 answer is 571. So this will be a minus 571 kilojoules. So when you calculate here this, and we want to get this equation, then you have to inverse this equation. This methane is on the reactant side, it must go towards the product side. So this is the equation number 6. So I am going to reverse this. So this is the carbon dioxide gas plus 2 moles of water liquid to form 1 mole of methane gas plus 2 moles of oxygen gas. Just I reverse this equation. So the sign is going to be changed plus 890.4 kilojoules. Now I will add. I'm going to add these three equations, different colors that you can see very well. I'm going to add these 4, 5 and 6 equations together. So dear students, there is the carbon dioxide gas on the product side and reactant side cancelled, same number of moles. On the opposite sides, they are going to be cancelled out. 2 moles of water, liquid 2 moles of water, must write these states, gas and liquid, they will not cancel. Liquid 2 moles, they will be cancelled out. No more water, no more carbon dioxide gas. Oxygen. There is the oxygen also. 1 mole of oxygen, and also there is also oxygen is going to be cancelled. Here. 1 mole of oxygen is here, 1 mole of oxygen are here. So there are 2 moles and there are 2 moles of oxygen in the combustion equation. When we combust it, now I inverse it. Both are different sides, they are going to be cancelled out. So what is remain behind? Carbon solid. This is a carbon solid and 2 moles of hydrogen. Gas. And no more other, oxygen is cancelled, carbon dioxide gas is cancelled, water is cancelled, so no more other. And carbon dioxide gas is cancelled, water is cancelled, oxygen is cancelled. So you have a methane gas. Now match this equation. This is 100% same. Then values. Now you have the value 393.5 plus 571. This will be 964.5. This answer minus 890.4 is equal to 74. So now students, don't put the minus in the calculator. This value is a minus greater value and this is a plus value, which is a less value. That's why delta H naught, formation of methane, put the minus value 74.1 kilojoules per mole. So this is your answer. If you check your book, 74.6, maybe some values are going to be different and you have to calculate yourself. The procedure is given and I told you the same procedure which is given in your book. In the 1 or 2 minutes I am going to explain. This is a question. Calculate the heat of formation of 1 mole of methane by using this data, given data. Question is, this is a question. The given data is formation of 1 mole of water. This value will be provided. Formation of 1 mole of carbon dioxide or combustion of carbon in oxygen to give a carbon dioxide gas. Exothermic process. This value will be provided for you. Then to get this equation, I am going to combust the required products. That's a methane is going to be combust, must give carbon dioxide gas and water without disturbing this, because this value is for the 1 mole. So you have to balance, and I balance this one. So this is provided from the examiner. Then by getting this equation, so I must equalize the carbon dioxide gas and water. So I write as it is this equation, no disturbance. Then 2 moles of water, so you have to multiply by 2 this. So I multiply by 2 this water, yes, and with value also. Sometimes the students, they forgot to multiply this value, so must multiply this 571 kilojoules for the 2 moles of water. Then to get this equation, I inverse this combustion equations. So when I inverse this, you will get this. So this sign must be a change when you inversing the equation, minus change into plus. Then add these 3 equations. When I add these 3 equations, all other are cancelled except 1 mole of carbon, 2 moles of hydrogen on the reactant side, and 1 mole of methane will remain behind on the product side. Add these 2 because there are 2 same signs, minus signs. You will get the answer subtract, because this is greater, this is less. Because minus sign is greater, I put minus sign, and you will get the answer 74.1 minus. So this is the standard enthalpy of formation of methane according to Hess's law of constant heat summation. So dear students, this pattern, this method is given for you and you have to calculate. Before starting new topic, I am giving you one. You have to solve all the numericals concerning these topics. I am going to solve one more for you. I am going to solve one more for you. There is a 21 combustion. You have to solve this one, and there is a 23. 23 is a similar that. So okay, I am going to see which I am going to solve, and there is another one. So there is one question more, yes, for the glucose, question number 21, and there is one more for benzene also. Calculate the standard enthalpy of formation of benzene C6H6, question number 22. Question number 22 and also 23, and there is also other questions. Okay, so the similar questions I am going to do. Suppose I am going to do question number 23 according to your exercise questions. I am going to omit this. So you have to see well. You have to see well this one, and you have to write in your copies. I am going to now solve. The question is, calculate Calculate the standard enthalpy of formation of acetic acid now. This is a question. This is the formula of acetic acid liquid, and delta H not formation question. This is the question, and it is formed from carbon. This is the one, this is the carbon one. Carbon is a solid, I must write in this form, carbon solid plus hydrogen. There are 3 are here and 1 is there are 4. So 2 H2 gas plus there are 2 oxygen. That is one. So this is the question, and this information will be the same. This information will be same. 1 mole of water must write this value. 1 mole of carbon dioxide gas, this same value. Now, and the previous practice, I combust the methane. Now I will combust the carboxylic acid, which is called acetic acid, ethanoic acid. So students, this is equation number 3. So I am going to combust ethanoic acid, liquid. Combustion means in the presence of oxygen. Full combustion, complete combustion, carbon dioxide gas, because incomplete combustion way you produce carbon monoxide. Avoid this. Water, liquid, and heat of combustion. Standard heat of combustion of acetic acid will be provided from the examiner, and the value is here. Standard enthalpy of combustion of the acetic acid is 800 minus 875 kilojoules. Minus 875 kilojoules is the standard enthalpy of combustion of the acetic acid. So the same informations I told you provided from the examiners. This is our required. This is the required equation. In the last, you must get this equation 100% same, because we want to prepare form 1 mole of the carboxylic acid. So dear students, I told you these are the main equations for you. These are the main equations. And you are finding 1 mole of carbon dioxide gas, and but here carbon 1 and 1 2. So that is why multiply by 2 carbon. Hydrogen 3 plus 1 4, multiply by 2 this one. Oxygen 2 multiply by 2 4 on the product side, and 2 means 6. There are 2, so there are 2 multiply by 2. 2 multiply by 2 4 and 2 6. 2 multiply by 2 4 and 2 6. The equation is balanced without disturbing this. Now here you are finding in the main combustion equation 2 moles of carbon dioxide gas, because there is no carbon dioxide gas, it should be cancelled. I must multiply by 2 this. Water, there are 2 moles, there are no water here, again I must multiply by 2 this. So, to make the equation number 4, I must multiply this equation by 2. So 2H2 gas plus oxygen gas to give 2 moles of water liquid. Delta H naught is equal to 285.5 multiplied by 2. The answer is 571. So I must write minus 571 kilojoules after multiplication. Then equation number 5, same procedure I am adopting. So here is again 2 moles of carbon dioxide gas. I must multiply by this 2. So this is the 2 carbon solid plus 2 oxygen gas to make the 2 moles of carbon dioxide gas. So I am going to multiply this also by the 2 because there are 2 moles. So minus, don't put the minus, 393.5 multiplied by 2, the answer is 787. So minus 787 kilojoules. This is the multiplication. And I told you that there is no carbon dioxide gas, there is no water here. So it must be cancelled. So I must reverse this equation. So by reversing this equation number this 3 to make a 6th equation now, reversing 2 moles of carbon dioxide gas and 2 moles of water liquid produce 1 mole of carboxylic acid, acetic acid in the liquid, and 2 moles of oxygen gas. Delta H naught sign will be changed, so it will be a plus 875 kilojoules. Now you add this equation now. So carbon dioxide gas, reactant side 2 moles, carbon dioxide gas cancel 2 moles on both different sides. 2 moles of water also cancelled out. And you are seeing there is only 1 mole of the oxygen. So that it should be only 2 you have. So there is 2 moles of oxygen and 2 moles of oxygen cancelled. There is 1 mole here present. So now I am going to write the product. This is not cancelled. I am writing this one. So required equation contains 2 moles of carbon solid as our this equation 2 moles solid. Yes, there is 2 moles of hydrogen, no cancellation here, plus 2 moles of hydrogen gas also put these states must, and 1 mole of oxygen, 1 mole of oxygen, there is 1 mole of oxygen. So these are the reactant sides, 100% same. Then product side, if you see, water 2 moles cancelled, 2 moles of carbon dioxide gas cancelled, 2 moles of oxygen cancelled. So you have only 1 mole of acetic acid. Acetic acid derived from acetium means vinegar. This acid is present in the vinegar. 5% W or W solution is of water is called a vinegar silica. Okay. So CH3COOH carboxylic acid 1 mole is going to be formed. Formation. Now 8, 5, 7, 1 plus 7, 8, 7, answer 1, 3, 5, 8. Then subtract 8, 7, 5. The answer is 483 exactly. Yes, 483, but the sign must be reverse. Minus 483 kilojoules per mole. This is the required answer with required equation. Required answer must be correct here, and this is the required chemical equation. It must be 100% same as this. Here must be variation, some according to values here, some variation may be here. So, but this equation must be similar after solving completely. So, the same procedure I adopted here according to the Hess's law of constant heat summation. We calculate the change in enthalpy of formation of different compounds by indirect way, indirect method. So students, next other you have to also solve these questions according to requirement from the exercise questions. Now I am going to start the last topic of this chapter, Born-Haber cycle. Before this starting, there is one also small calculation enthalpies. So please, this is very important. Many times come in examination. Very carefully you have to solve with the values also, and careful about the signs, positive or negative. Enthalpies are reaction from enthalpies of formation. Enthalpies of reactions, article 11.81. Enthalpies of reactions from enthalpies of formation. It is often convenient to calculate change in enthalpy values from the reactions from the value of standard enthalpy of formation, which will be given for you of the reactants and products for the given chemical reactions. So there is a formula. You must remember this formula. You want to calculate enthalpy change delta H naught for the reaction must be equal to, this is the sigma capital, coefficient in the balanced chemical equation for the products, P for the products, delta H naught formation. Products, sigma capital, coefficient in the balanced chemical equation of the product for the formation of that. Products, this I am writing again. This is for the product. minus capital sigma coefficient. This is coefficient for the reactants delta H naught formation for the reactants. This is a minus. Yes. This is the formula. Use this formula. Calculate the standard enthalpy of the reaction. So values will be provided for you, chemical equation will be given. But one thing I want to explain you, enthalpy of the formation of the some molecules at their standard state is 0. Oxygen gas, nitrogen gas, hydrogen gas, elements, iron element, copper element, any elemental form or molecular gases, they have the 0 value. Standard of the elements written in the book is going to be 0. So dear students, here is one equation. We want to find this. Equation we have to form, calculate the change in enthalpy of reaction or the following reaction which takes place when gasoline, petrol, 2 moles of petrol, octane, oct, 8, C8H18, gasoline is going to burn with 25 moles of oxygen gas. It burns completely if the car engine is a good and fuel is a good, does not contain lead. So it forms 16 moles of carbon dioxide gas. If you use in your vehicle, because nowadays big problem for the whole world, pollution, air pollution, very bad effects, adverse effects. You must use the catalytic converters in your vehicles. 18 moles of water, according to balanced chemical equation. So calculate the change in enthalpy of this reaction. Values will be provided for you. All the values are given and you have to put. So change in enthalpy of reaction, above reaction is sigma coefficient of the product. Change in enthalpy formation for these products mean these are the products and these are the reactants. So I must put these values on this side, then subtract this side will be here according to formula given. So dear students, 16 moles of carbon dioxide gas, products 16 multiplied by change in enthalpy of formation for the carbon dioxide gas plus 18 moles change in enthalpy for the formation for water. This is the product side. Product side, I reach here, this up to here. I put here in the formula. Sign is negative, put say negative sign. Then 2 moles of octane, 2 multiplied by change in enthalpy for the formation of octane C8H18 liquid. Then plus 25 multiplied by change or enthalpy of the formation of the for oxygen gas. This is the formula. I put all these reactant product side and reaction. This now you have to put the values. Delta H naught reaction 16 multiplied by, this is the carbon dioxide gas, you know, minus 393.5. So minus 393.5 kilojoules for the carbon dioxide gas multiplied by 16, yes, plus, then sign is minus 18 multiplied by minus for the water 280 minus 285.8 kilojoules. This is for the water, and sign is minus, and there are 2 moles of octane. Yes, so 2 moles of octane minus the value you can see for the octane is 269 kilojoules for the octane, and the oxygen will be 0, like this. Now if you solve this, if you are going to solve 16 multiplied by 393.5, this will be a 6,000. So delta H not reaction is equal to minus 6,296, and then you have the carbon dioxide gas, then water 18 multiplied by 285.8, the answer is 5,114, sign is minus 5,144. This side we complete. Now minus into minus plus, minus into minus plus, so there is 2 multiplied by 269. The answer is 538. 538. This is a 0, so don't put this. Now these are the 2 minus, must add. Delta H naught for the reaction is equal to 6296 plus 5144.4. This will be a minus 11440.4. One one four four one one four four point 4, then minus 1144.4. Then plus 538, so minus 538, so you will get answer 109 0.4 0 minus 5 3 8. Yes, the answer is minus 1 0 9 0 2.4. This is your answer. If you write in the exponential notations 1 2 3 4, so minus 1.09024 into 10 raised to power 4 kilojoule. This is the heat of reaction. So by using the same method, there is another example. Calculate yourself 11.17 for the combustion of glucose. So we finish here, then I'll start in the next lecture Born-Haber cycle. This is a lost topic for you. Thank you very much.